When I started out my career, I had an interest in science and in technology and all aspects of scientific development. And although I've been an educator, an educational researcher, a teacher for decades now, that early experience of my life has shaped the way that I see things. Now, I'm not making apologies for this. I think that we all have a history that shapes how we see things. And one of the things that I do, sometimes it seems like it's the only thing I do, but one of the things I do is try to explain how I see things through the eyes of experiences and techniques and methods that I learned when I was an engineering student a very long time ago. And this week, and not only this week because it's going to take more than one video, but this week I want to explain to you a technique known as data envelope analysis. Or DEA. Perhaps we might also come across it called data envelopment analysis, but you'll recognise it's similar enough. Now, the idea of this is that it's a technique that engineers use, particularly, though it's got wider application, particularly used for comparing units that are not directly comparable. Let me explain what I mean by that. Suppose you've got a car factory that manufactures cars, or you've got a car factory that manufactures vans, or you've got a car factory that manufactures some cars and some vans. How could you compare those different factories? So the idea of data envelope analysis is that you take some dimensions that you want to assess and you take some inputs and some outputs, and let's suppose we're trying to produce cars by some measure of the inputs. How many cars per worker? Let's say number of cars per worker produced per week. Or number of vans per worker. We've got cars per worker, vans per worker, and a factory that produces only cars might be over here, producing so many cars per worker. And a factory that produces only vans might be producing so many vans per worker, and somewhere in between, a factory that produces a mixture of vans and cars will be somewhere there. And we might be wanting to compare dozens of factories that produce a different mixture of cars and vans. And we'll plot them all on the graph. And what we're looking for is the envelope that encloses the most successful ones. We're looking for something like that. The boundary, none of them have got beyond that boundary, but we might say the closer they are to that boundary, this factory here is producing more cars and more vans per worker than this factory here. The factories that are close to the boundaries are performing better. And so we might take it as a standard of comparison that the distance they are from the envelope explains how well they're doing. That's the basic idea behind data envelope analysis, is that this factory here will be compared with the closest point on the envelope, on the boundary, while this one will be compared with the closest point on the boundary. that means that like is being compared with like. We're not comparing a factory that produces only cars with a factory that produces only vans. We're comparing with the nearest, closest relevant point of comparison. And that's all there is to, really, the basic idea of data envelope analysis. And it's the example, manufacturing, cars and vans, it sounds like a very engineering sort of application. But it doesn't need to be just about engineering applications. Suppose we had supermarkets and we wanted to compare supermarkets that sold a lot of food with supermarkets that sold a lot of household goods. We've got supermarkets in different locations, and so we could put supermarkets in centre of town, probably sell more food. Supermarkets in retail parks perhaps sell more household goods, and we would by comparing with the envelope, comparing with the boundary, we could compare supermarkets that had different performance between those different locations, different ranges, rather than simply expecting the manager of every supermarket to produce the same kind of sales figures. We would take into account the kind of clientele, the kind of people who are buying from that supermarket. Now, I want to go on to say, this seems to me to be, for example, a good way of comparing universities that are producing research outputs and comparing teaching outputs. We know that universities have different profiles. We have primarily research universities and primarily teaching universities. I'll come back to that later. Before I get to that, I'll actually come back to that in a separate video, but before I get to that, I want to talk a little bit more about data envelope analysis. The concept is basically very simple. The concept is we draw the envelope around the envelope is fixed by the ones that are most successful, and then effectively the process looks like this. This boundary here is an ideal kind of factory that's very similar in output and level of production to this one here, and so we're comparing each factory with a kind of ideal that is constructed from the best, the performance of the best. Now, it's a system of comparison that's actually very sensitive to whether you've included all of the right exemplars that you want to. If I've missed a factory that is really outstanding up here, that would change the envelope completely, and it would also change the relative performance of all of these other units that I'm considering. So, missing a fine example will affect the outcome. So it's very sensitive to whether you've got all the right examples in the first place. So it's a method that needs to be treated with some respect and to be treated with some care. And the other thing is, I've given you an example with 2 dimensions. And of course, I've given you an example with 2 dimensions because I'm drawing it on the board, and that means it's easier to visualise if it's in 2 dimensions. It can be done in 3 dimensions. We could, in the supermarket case, for example, divide food into frozen food and fresh food and distinguish between the 2 different kinds of food and compare against with household goods, and we then have a 3-dimensional model. and in fact you can carry on doing that more and more. You can add dimensions notionally, mathematically, and if you carry on doing that long enough, what you discover is that if you have a dimension for every supermarket that you're comparing, or a dimension for every factory that you're comparing, then all you discover is that every factory is different, every supermarket is different, and there's no possible comparisons. It's a truism that context matters, but if you make context everything, you can't compare, because all that happens is you learn that every unit of assessment that you're looking at has its own profile and performs in its own particular way. So I like this technique for two reasons. It treats inputs and outputs separately. The input of number of workers you got, or the number of hours, you can increase the complexity of the model in terms of inputs and outputs, but it treats inputs and outputs differently. Effectively, what we're asking is, how can we produce more of the output, whatever it is that's desirable, with the same level of input or the same level of resources? Now, of course, you have to be able to measure them in order to be able to fit them into the model, but it doesn't have to be money. It often is money that we're trying to can we do more with the same amount of money? Can we do more with the same number of teachers? Can we do more with the same number of workers? But we're trying to maximise the production of what we want and minimise the necessary resources that we put in. And the basic idea is that. Now, data envelope analysis has been used in the social sciences. It's been advocated by Anand Desai, for example, and he was criticised for doing that by Harvey Goldstein, who's a statistician, who said if there's a relationship between inputs and outputs, you don't want a rough and ready scheme like data envelope analysis in order to analyse it. You want to know exactly what the relationship is. And Anand Desai says, well, it's hypothesis generating. We can see, we get a hunch as to what makes an efficient factory or an efficient supermarket, and we can generate hypotheses that we look at later. But I think it goes slightly deeper than that. It's partly a question of how you see the world. If you think the relationship between inputs and outputs is out there, if you think that it's in the world as an objective fact, that if you put more input in, you'll get more output out, I mean, I think that's rather doubtful, then you'll prefer Harvey Goldstein's answer, which is to say, let's use regression analysis, let's look for the actual relationships that are in the world. If you're saying it's about telling ourselves stories, telling ourselves plausible stories about what makes a good factory or a good supermarket or an effective manager, then we look at information and try to put it into some sort of pattern for ourselves. Then you're with Anand Desai, and that seems to me a kind of fundamental difference. I personally don't think that it always is the case. I know people assume this, but if you put more money in, it doesn't necessarily solve problems. It doesn't necessarily do any harm either. But in data envelope analysis, those assumptions are not built in. We can have a look and see which resources go in, and there's well-established commercial software that will allow you to put in a lot of different variables as inputs and a lot of different variables as outputs. And it's that process, it's that use of data envelope analysis that I want to take away from here, and I'm going to go in my next video and look at data envelope analysis as applied to university performance using other people's indicators. So that's general about data envelope analysis. It's a technique. It's not perfect. No technique is perfect. It has some features that appeal to me. It treats inputs and outputs as separate. It treats comparison. It compares the performance of a factory with like factories that are in the same part of the graph as it is itself, and it's to me makes sense as a way of comparing performance. It's got this major disadvantage, is that if you miss out an exemplar of high performance, it will affect all of the results that follow, because effectively each unit is being compared with the boundary, and the boundary is set by the exemplars that form this outside layer. So that's data envelope analysis in a nutshell, and I'll go on in my next video to talk about how I have applied this to an examination of university performance in the UK but elsewhere.